Welcome to SEC 205, 5.5 things and actions you can take to mitigate software supply chain risk and threats. I'm Andy Chang, one of the product management leads in cloud security focused on software supply chain. I'm joined here by Aron.
Hello, everyone. Aron Eidelman. I'm a developer relations engineer focused on cloud operations and security.
And today we're going to walk you through a few things. Split between the two of us, we'll talk a little bit about the context of why software supply chain is increasingly important, something you guys now to think about and expand upon beyond traditional app security. The actual threat landscape, which Aron will cover. We'll cover those 5.5 things, with Aron taking the first half and me taking the second half of things. And then we'll talk to you about assured open source, which is one of the first initiatives Google has from a product standpoint to help you guys make your lives a little bit simpler. So we'll start off with kind of an interesting concept. Today, whether you know it or not, you're a software company. You depend more and more on software to deliver value to your customers. As a result of that, you're subject to a lot of the risks that exist in the whole supply chain leading up to that software. And tell you more about the risk landscape, and I turn it over to Aron.
Thank you for that, Andy. So it's interesting with risks that are specific in the supply chain. A lot of these threats are going to look familiar, but the aspect is slightly different because it's happening at a different stage. And why does this matter to you? You know, I had a chance to see some of the different industries that are represented today, and not all of them would say we are primarily application developers. We have everything from manufacturing to national security, so why does this actually matter to all of us? Because today we're at the end of the supply chain, at the very least, right? We're consumers. And very often we're consumers of open source software. Now, Google anticipated that there would be an issue with this for over a decade, and we've taken a lot of steps to refine our process, our mitigations, and we want to share some of that with you too. In Mandiant M Trends, we've seen that 17% of breaches start with a supply chain attack, and that it is now the #2 initial infection vector. Now, analysts think that within the next 2 years, nearly half of companies are going to experience a supply chain attack. And because of that, there has been a lot of response from governments and regulators to improve how we have visibility and preemptive action into preventing these attacks. I also want you to take a look at how these attacks are changing, becoming more sophisticated. There's more of an expression of creativity in them. For example, with 3CX, the threat actor was able to chain together multiple compromises. And then with PyPy, they deliberately overwhelmed maintainers with malicious packages to the point that the maintainers were not able to respond in time. So because of this, I want us to think of supply chain security as much more than just accidents being introduced, the typical dependency management with accidental vulnerabilities, either from open source packages or from our own developers. Instead, we need to take a more adversarial perspective here. We need to think there are people who are going to deceive, to take advantage of how we operate, to get things in early because it's easier at that point. And so just to look at this landscape and see, a stoic exercise, what's under our control and what's outside of our control? Well, under our control, we have our own pipeline, all the single steps in our build process. And because of that, we need to check the integrity of the artifact at every single point, not just from source in runtime. We need to look in between. Am I pulling the right package? Am I releasing the right package, right? Every single step we need to scrutinize. And runtime security will still be relevant, but it's not the only thing. So we need to think also about the things that are less under our control, right? Our dependencies. Now, for every single dependency you bring in, you may bring in 70 to 80 transitive dependencies. So really think about that. For the 1 or 2 people talking on stage, there's a whole audience, 70 to 100 people, right? Same thing with your dependencies. So think about the visibility issues that come up here. Every single one of these dependencies also has a pipeline that's also susceptible. Even if source has the right scrutiny, and even if runtime has the right scrutiny, there's all these steps in between that we'll go into where things can go wrong. And just to hear both what we've heard from Mandiant and also directly from our customers about the pain points around this, we see that there is a 7x increase in open source supply chain attacks, and likewise, that 85% of vulnerabilities are in these transitive dependencies. And I mentioned earlier that by 2025, nearly half of organizations will experience an attack. So governments and regulators have really started responding to this. In 2021, starting with Israel and the United States, and by 2025, with regulations rolling out in Europe and APAC. And many of those regulations in the US just a couple months ago. So now that we have a leveling of the problem space, let's start to think about some of the actions that we can take. So I mentioned earlier the difference between what's under our control and what's outside our control. So think about those things outside our control. How can we mitigate them? Well, we can increase our visibility. Now, at the risk of being painfully obvious, that you can't secure what you can't see, there is a take-home point here, right? And it's seeing what's relevant to you and your organization. And you can think of it in many ways the same way you think of food, right? You cannot possibly source all of the ingredients of the food that you eat. You rely on someone else to do that for you. When you look at your food and it has an organic label and nutritional facts, you have some assurance that someone else has tested this for you. And similarly, as Andy's going to talk about later, Google wants to share a lot of the practices that we have, and really a list of the actual packages with you to show you that we vetted that entire process. But in terms of how ingredients get tampered with, right, in terms of how things can change unintentionally, looking at this list, 1 and 7 should look pretty familiar, right? This is where we already have our visibility focused, at source and at runtime. At source, we have developers reviewing PRs, really actively looking at the code that's being introduced. And then at runtime, we have our operators, so we have our security teams looking at how things work in production. But we shouldn't take for granted 2 through 6, everything that happens between, right? We also should not take that for granted in the dependencies that we're using. We can't just count on source control being the point where security takes place. To give a good example of things that happen in the middle, look at Code Cove in 2021, where a malicious actor got credentials to a GCS bucket and uploaded a malicious package. Still included the working code. Everything looked good in source, but the package was in the place where developers are pulling from. So now that we have a sense of why we need to care about visibility, let's look at all the different ways that we can get owned beyond just vulnerabilities. So 1 through 3 should look awfully familiar. There is nothing new here. What is new, however, is the place at which these things are being introduced. Right? We've dealt with malware and typo squatting forever. But think about typo squatting, for example, or using a similarly named website that turns out to be a malicious one. Initially, that was intended at employees of a company or customers of a company to send them to a phishing site. Now, however, we're seeing the same technique being applied to developers. A good example would be Colorama, where color with the British spelling with an additional U contained a malicious package. So for anyone who naturally spells color with a U, it was very intentionally easy to bring this in. And the mitigations to this, think about it. Just looking at CVEs is not going to catch something of this nature. What you need is threat intelligence. You need to have insight into how the open source packages are being used, like how many people are consuming it. There's a lot more than just the traditional vulnerabilities. Similarly, beyond vulnerabilities, there's how things work in production, in runtime. And this has been a big focus in application security, where all the noise of CVEs and CVSS scores that were not relevant to an organization has come to a head. And we realize it's overwhelming. It's combinatorially explosive. We care about the things that apply to us, not every single vulnerability under the sun. So seeing the way that vulnerabilities can be chained together, and especially in our dependencies, which is sometimes concealed from us, is key here. So now that we have a sense of the need to increase visibility, right, not just in general, but in depth to the things that matter to us, and also a sense that we're not just managing vulnerabilities. There's active threats early in our environment. Let's start to think about how we can form a consistent way of determining whether to know or trust a supplier. Right? This is CISA's requirement. And you look at this initially and you say, well, how do I know or trust anyone? But there's a consistent set of traits that we can look for that helps to give us assurance. And there's a lot here. The through line is that if one of these fails, the others are like a strand of rope that support the rest of the process, right? And I really want to call your attention to 2 and 8, provenance and attestation, and showing evidence of assurance. Looking back at our ingredients, this is really our way of saying for all the potentially millions of transitive dependencies we're using, we have as best a sense as possible that they have gone through the right process to deliver this to us. So with all that said, I want to introduce Andy back to the stage to show some of those solutions that we have.
Thanks, Aaron. So how many of you folks have heard about SBOMs? Raise your hand. How many folks think you know what you're going to be doing with your SBOMs? Right. So I think one of the key things is, as Aaron pointed out, it's super important to know your surface, your attack surface, so all the pieces that compose your software. So SBOMs do a great job there. But as we'll talk a little bit more, there's nuances about both where SBOMs are generated, the type of information you get from them today that set a min bar, and where more you can do with them. So minimally, CISA's requirements, not surprisingly, are you obviously have to identify your package, you know where it came from, you know the vulnerabilities, you know the dependency chain, you know how the licensing and when this was last checked. The challenge is there are multiple ways for you to get SBOMs. So when you look at the source code side, you're getting essentially the build information of all the possible things that can be pulled in. As you go through the pipeline, you start mixing build dependencies with potentially packaging and runtime dependencies. And ultimately, when you get into production, you have dependency injection cases. You have cases where different aspects of the code replicated versions of functions call slightly different dependencies. So it's important to know as you go through here what information is solid and assured at each point and what you actually have to make up for. Nice thing about runtime, you'll see, especially in things like Java, just the dependencies you pull in, but you won't then see by their name what the transitive dependencies there are from there. So you have to stitch it all together. Key thing then is using the version of the SBOM when you've gotten it for the right purpose. Right, so number one, as we talked about, your attack surface, your dependencies are not static, they're dynamic. What you have in build, only a subset of those are likely to be used by the calling function, the call graph, the actual running, and it can change run to run. So being able to understand how those dependencies are being used, if you've pinned the dependencies, so actually you get a specific known version, or it's a range or a version above, so now what you're dependent on will change over time as the package updates. Those are all things that you have to factor in when you start generating your SBOM. If your goal, first and foremost, is to establish a basic list that you can serve to others, you're able to do that effectively, but you have to dive in more if you actually want to use these now to effectively impact your security. So as the surface dependencies can evolve and change over time with the stage, it's important also to figure out, and I think most of us have seen this, it's actually pretty straightforward to find big lists of vulnerabilities. The hard part is to figure out how to prioritize them, which ones are relevant, and ultimately which ones are exploitable, because if you have limited resources, you need to focus on the ones that have the most risk and security impact. And some of the characteristics of what gets involved in determining what to prioritize are, number one, not surprisingly, the nature of the vulnerability itself, its criticality. But also important is what else is in the code that you're running, and are there chainable paths between different vulnerabilities, which may not be as critical, but together allow a customer to or the threat actor to exploit things. And then at each stage, are things reachable, right? So if you're running an innovation workload in a totally clean room, air-gapped area, network vulnerabilities are probably less impactful. If you're running it on the public internet, they're hugely impactful. And then the other piece that's missing in traditional app security from purely the workload and application side is what's the effect and impact of contextual security. So applications don't run in a vacuum. They run in an actual infrastructure with security controls that are in the environment around it. So whether you have WAF rules, you have RASP, you have other technologies in place that can block particular types of input injection, those also impact whether the particular vulnerability is critical to you in context. So net-net, that effective security and risk is really a function of the intersection of what's reachable and callable and what is the environmental applied security controls. In addition, as we just talked about through the different places you can get SBOM, it's important, again, to know the limitations of where you're pulling the SBOM from, how much insight it's giving you either into the list of dependencies you have and the ones that matter. And then I think there's an importance to think about assurance, like what is the guarantee that the SBOM you're generating reflects the true state. So again, if you're scanning binaries, you're going to get the packages that are listed in the dependency, but you're not necessarily going to just get their transitive dependencies because those are called by that package unless you have to then scan the binary of those. And so it's important as a provider of SBOMs to understand where those boundaries are, to be clear and declare for your customers, internal or external, whether security, regulatory, audit, what you actually control and where that limit is for vulnerabilities, for dependencies, and for the chaining of those together. Specifically, if you don't get the dependency list, you've now left a huge attack surface that's available and exploitable by bad guys. And for us at Google, as Aron pointed out, beyond just the minimal things you put into SBOMs, we think about the plus, right? In addition, knowing what security tools were run against that, what versions of those security tools. Understanding the community health, the package health, the contributor health and risk, right? Understanding whether the most recent PRs and updates are anomalous or in line. Understanding how overall the community responds to patches. Those are additional pieces of information. Understanding the posture of that project through something like OpenSSF Security Scorecard. Those are additional pieces of information that help you assess the risk of a particular package as you guys choose to allow it, as you guys choose to use it, and understand how quickly it updates. One of the things we do in Google Cloud is we try to make this easier for you at that first step of managing SBOMs. So our artifact registry product allows you first to, for any set of packages or images in AR, export and generate SBOM files in SPDX format. In addition, for any SPDX or SBOM files, you can query those using our container analysis APIs to understand the details of those things. Third, if you want to make this a central home for SBOMs, you can ingest SBOMs, and they will be cataloged and processed the same way. And staying tuned, we also are going to be implementing push generation. So you can load artifacts, and as soon as an artifact is loaded into artifact registry, it will generate SBOMs in SPDX format as well. In addition, a corollary to the SBOMs is the VEX information. We just talked about it's not sufficient just to know there are critical vulnerabilities. It's part of the responsibility ultimately for you to understand and manage your software estate, to understand and communicate if your software is affected by that vulnerability, if you understand how to fix it, or if it's still under investigation. So similarly, Artifact Registry today allows you to manage VEX statements and VEX files within AR. You can ingest them, and then you can either query them through APIs, or in the Google Cloud UI, you can view them, display them, and overall understand them better. The fifth item we're going to focus on is really the concept of provenance and attestations. This gets back to that theme that Aron talked about the risk patterns related to integrity. So integrity matters, and it's important then as you go through the process to understand what's happening to the artifacts as they go forward. So when you think about provenance and attestation, number one, you have to log events. You have to know what actually is happening in the transformation of those artifacts as they go through the pipeline. Number two, attribution. Who is doing the actions, whether it's a human, a machine, a service? And then number three, how are you validating that that log is correct, right? Attestation, so having separate attesters be able to look over the logs, make sure the actions that are being recorded are correct, and then sign them so they're tamper evident. This gets into signatures. One of the key aspects of how we do things at Google is at every stage we sign the artifact on ingest, on egress, and therefore able to check at each stage of the pipeline the integrity and, in fact, if the policies that we expect to have happen have actually happened for that. Something that now is pushing forward to an underlying infrastructure is the ability to use now public ledgers, things like SigStore as a technology, so that not only within your own view you understand what is the integrity, what's the evidence around a particular package, but now in a public ledger for either your partners, your customers, the ability to have that type of confidence and validation be able to be checked without your intervention. And the last thing is to apply policy, right? So this is great to have attestation, provenance, and tracking. If you're not going to actually then use that to control the ability for something to progress through the pipeline, then you're not really taking full advantage of the opportunity here. The half thing that we talked about is, at the end of the day, there are many good software security and software supply chain frameworks. A key thing that we would advise is for you guys to pick one, right? Because you need to understand how you baseline where you are today and what are the steps to get better. And so classically, you need to take the first step, and if you don't start measuring, there's no path then to improve. So if you look at a couple, Salsa, which has its origins in Google and how we do software supply chain security, its main focus is on a few things: integrity, logical control points like a single build service, non-unilateralism, and ultimately provenance and attestation, so you can understand and prove the integrity of the artifact throughout. If you look at SSDF, a lot of the work is around how you as a developer can work through things. Section 4 in the 1.1 expands to include the executive order pieces around software supply chain. So our recommendation is, there are a lot of good frameworks. Make sure the framework that you're picking has a key component and guidance and measurables around software supply chain as an additional vector. And then what's important is to get started. So first step, do you know how open source or external code gets into your system? Do you have an inventory of all the different ways your development teams actually can pull code into your system? And are you controlling them, right? So without that, you're going to not be able to stop the bleeding. Next, once you understand how the paths are, do you have a sense of what you're actually using, right? Of the different packages in production. Do you know which versions, how many different versions, which types of packages? If you're using containers, do you have a huge image registry of which only 1 or 2 are actually in production? The ability to understand what you're using is going to help you in remediation response if a new significant vulnerability comes up. And then on the other side of ingest, right, how many different paths are there for development teams to get to production? Right, that's another opportunity for you to put a logical choke point. So you can have many developers if you can control ingest. If you can control egress to production, you now have a couple different gates that we can start managing the problem space and the complexity. Next, it's important, as you start measuring, to figure out how many things are actually going through your planned happy path. Our approach at Google is it's a mix of carrot and stick. Developers are creative. If you don't make sure this is actually beneficial to them, gives them a smoother path into production, you're going to get resistance. Also, one of the things to understand here is, from a security team standpoint, are you a security team that's able to break builds, or are you a security team that's ultimately only able to alert? The distinction there is who gets the last say about something going into production or whether production's halted. Based on understanding that, you can then figure out, if you are a team that can break builds, with great power comes great responsibility. You again really need to start looking at how many things go through the happy path, because you need your developers to be bought in, especially if you're going to be able to have the power to ultimately break builds. Similar to understanding what number of teams are going through the happy path, understanding what are the exceptions. What do you need to do to both categorize those exceptions, understand what are the next big chunk of work to help you make your developers overall more successful, more secure as they push things to production. And then with any framework, there are pluses and minuses. Understand those gaps, and then you now can pivot resources to be more focused on the areas where there are gaps. So one of the ways we're looking at making this easier for you is with our assured open source software service. Again, as Aron pointed out, there are 5 areas of risk. The one that everyone's most familiar with is number 3, vulnerabilities and runtime. But with assured open source, we try to address all 5, and we'll talk a little bit about how. So assured open source is generally available, became generally available in April. It's really focused on a few things. Google being one of the known and trusted suppliers of open source software for you. Number 2, taking what we do in security for open source for ourselves and making that apply to packages that you may use from open source, also allowing you to use packages we use within Google that have gone through security testing, and provide enough metadata, SBOM, and VEX information to help you meet your regulatory, both internal and external security and risk requirements. So, number 1, assured open source is useful and available whether you're building on GCP or not. Developers could be building on a laptop, could be building on-prem, could be building in another cloud. We ultimately, from an interconnection interface standpoint, if you can reach Maven, you can reach PyPy, you can reach us. And we're able to then serve those secured packages to your developers. Number 2, to address the issue of tooling, repos, and process, it's built on a secure infrastructure. It's built fully within Google, using Google tools, controlled by Google end-to-end. We build these packages from source all the way through to binaries. For the second item, we just talked a lot about integrity and provenance. So we fully attest and sign the packages that go through our process. We provide a SALTA level 2 or SALTA level 3 attestation that's signed for you to look at. From a vulnerability standpoint, not only do we manage and scan for the existing vulnerabilities in the primary, the direct dependency, and the transdivs, we also use our proprietary scanning technology to be first to find for new vulnerabilities. So in addition to just managing what's in the CVE database, we're actually using fuzzing and other technologies to be first to find for a range of the new vulnerabilities. For the initial set that we've scanned, we find about 50% of all the new vulnerabilities are found by Google as the first to find for critical vulnerabilities. In addition, as we talked about, it's not just the primary, it's the dependencies and the transitive dependencies. So included in our software composition analysis for open source is dependency mapping and, in many cases, transitive closure of the build. So not only are we building from source for the primary, we're building from source for the dependency, and we're building from source the transitive dependencies. And as we talked about, right, in addition to being able to be secure, you need to be able to demonstrate to internal, external, security people, risk people, auditors, the level of your security. So we provide enriched metadata that's signed, again, so that's tamper evidence, SBOM data, the dependency data, the vulnerability impact in VEX, and licensing. So today, we have 2,500 of the most popular Java and Python packages available. We specifically in Python also focused on some of the key machine learning and data packages around TensorFlow, scikit-learn, Pandas, PyTorch. If you look at the threat vectors, if you remember before, right, understanding and controlling your open source, that's done through our generation of assured SBOMs and VEX. The critical vulnerabilities, whether they're existing or new, we do scanning and management for those, including shortening the ultimate fix-to-find lifecycle by being first to find. From protection against the things like typo squatting and dependency analysis, we do origin validation. So we're making sure that rather than your development teams pulling arbitrarily from a random location, we validated that where this is pulled from the core canonical location of the source code when we build it. It's in a Google secured repo, so taking advantage of the secure underlying infrastructure of Google Cloud and GCP to secure all the artifacts, the source code that we're pulling through the pipeline. And it's run through our process tools and our secure repos. And lastly, what we distribute to customers is signed, so it's tamper evident both in the underlying binary as well as the metadata that we serve. An example of some of the things that differentiate. So licensing is one of the aspects of risk. So for us, if we looked at the top 2,500 packages we served, 30% of them, if you look at open source locations and of data and information, have either unclear, unknown, or risky licenses. And so in addition to the standard scanning for licenses, we have proprietary technology in Google that looks at those license files and can further categorize those. And those are then added into the metadata for the packages we serve and curate. If we look at the way we think about package assurance, there are 4 levels of package assurance. First, that we do this, we talked about before, origin validation, so that all the, whether it's the images, the binaries, or the source code, is coming from the canonical location. Number 2, that the primary package is built from source by Google and attested. The 3rd level, where we've transitively closed the package, where not only the primary, the direct dependencies, and the transitives are built from source within Google. And the last, that it's differentially signed by, or scanned by our fuzzing technology and our remote code execution technology. So bringing this to a close, the kind of key takeaways are, number 1, there are a number of new threat and risk vectors in your attack surface. Traditionally, you've operated in 3, looking at runtime vulnerabilities, and many of the scanning tools now move that vulnerability finding earlier in the pipeline. But as Aron pointed out as well, we're living in an environment of active, intentional, malicious actors who are trying to inject malware into the system. And the other 4 areas are areas where they're actively putting malware in. Taking a look at this and how we would address this then, places to start are, number 1, know your ingredients. Know what's actually going in the software that you're building. Number 2, beyond the vulnerability management, vulnerability detection, think about the risk areas that are in your supply chain that malware can be injected by an active and creative threat actor. Use known and trusted suppliers. That helps you reduce your risk and reduce the number of things you have to trust. Require high-quality SBOMs that are assured. And as we talked about, SBOMs generated for the purpose you want to use them for at the stage that makes sense. Enforce provenance and attestation, so now you have a record of what's happening to the software as it transitions to the service. And ultimately, pick a framework, baseline, measure, and improve. So with that, I'm going to bring Aron back up. There's a number of other sessions that we're doing in security, if you have a deeper interest in security. And I want to thank you guys for your time.